Hello from the Engerati studio. I'm Rose Bundock and I'm joined now by Julian Green, Operational Technology at Oracle Utilities.
Hello.
Hello, Julian.
Nice to be with you this morning.
Yeah, we're going to focus our conversation on the low voltage network. So let's dive right in.
Mm-hmm.
There's a lot of darkness in that part of the grid at the moment.
Indeed.
So what drivers are you seeing to bring light?
Well, it's a very interesting question, and I think it's quite a topical one at the show here at European Utility Week. The challenge is that we're seeing a lot of disruption start to occur in that low voltage network. If you think about what you might be doing as a consumer, you might be investing in, some sort of renewable energy generation device or energy conservation device. You might be contemplating installing some storage, or indeed, maybe you're thinking about a move to an electric vehicle. All of those things create a lot of disruption for utilities in terms of managing the network and managing loads on the network. We've got some technologies that are helping improve that visibility, smart metering being one. And again, also, we're seeing a proliferation of cheaper sensing technologies that are using IP, for example, internet protocol to communicate, that's perhaps cheaper to deploy in larger numbers. What this does, of course, is create an information deluge that you need to manage. And that's what we've been concentrating on at Oracle with our network management system. And also with our asset management system is how do you take this information and turn it into actionable information, intelligence, and ultimately wisdom to be able to manage that network efficiently, more accurately, and essentially more reliably for the consumer. So in our network management system, it's very much focused on how do we collect all of that information together with the traditional SCADA and DMS technology that's been servicing the distribution utilities for long time, for long years of service and very reliably, and build on top of that to deal with this disruptive technology that we're actually seeing going in at the edge, and provide that unified view to be able to make those control engineers deliver that really efficient and robust service that we come to expect. Everybody expects when they flick that switch, those lights go on.
So there's a clear business case there for the utility to be able to monitor assets better. What energy use cases are you seeing particularly with your solution?
So certainly one of the things that we're starting to see as you start to see customers adopt their renewable generation technologies in greater densities, so it starts to become very important to understand that those customers do have that capacity to understand and to predict what those perhaps customer side generation capabilities are actually producing at any point in time. So to be able to understand, for example, if you've got a solar on the rooftop, based on the weather that we understand for that location at any point in time, what are those solar panels producing? So that we truly understand all of our loads on that part of the network, because to deal with any constraints that we may have, or to deal with any faults that may appear or start to occur, we need to truly understand what the actual load is and not necessarily what we're metering. Because very often what will happen is, let's say there is a fault, in order to protect you as a consumer, those customer side generation devices will actually trip out. So when you try and reintegrate you as a customer back into the network, the utility perhaps has been measuring a load from the meter going in, but actually there's a lot more load because of all that solar capacity that you've been using. And so when you start to respond to a network problem, you really need to understand what the true load is at each edge point, and that will make much more efficient sort of operational actions and give you the visibility of those different load curves that you need to dynamically manage the grid. The other thing that's interesting as well is, we've seen a great drive for electric vehicles, and these are quite disruptive. They've got significant loads that they bring onto the network when they're charging. And so being able to actually understand, based on load patterns, where these things may be starting to occur, is also good information for the utility. Consumptive information and measuring things like voltage and so on can also be very important in terms of assessing the health of the assets. You can actually put this into algorithmic tools to actually derive what you believe the loading on the devices are, and potentially some of the health characteristics and indices for these devices, and build that into your condition assessment capabilities for these assets. And particularly for the critical assets, you really want to have a real-time condition score so that you really understand the health of those critical assets in the network all of the time. And that's something that we've been doing in our work and asset management system, and the analytics that complement that to be able to bring these different types of assessment and the different channels of information that we can now collect against these critical assets, particularly as they become more intelligent, more communicative with the data, and turn that into, through algorithmic business rules, an assessment that balances the telemetry, perhaps the physical inspections that we're doing periodically on that asset, and perhaps some of the measures and tolerances that we may be able to calculate from the data we're collecting from that device to arrive at an overall health score. And that will hopefully then allow the utility to better optimize its operations and maintenance budget, and potentially also understand and have perhaps a better picture for some of the capital programs for replacement that they may want to drive. Because a lot of the time we're basing this on what we predict the asset to look like and the condition for it to be in. And what we want to do is give the utility that information to be able to base those decisions on real information, and perhaps, provide a bit more intelligence in terms of, some of the assets that we think we can sweat a little bit. And some of the assets that we know are being overloaded, we can now create that financial capacity to do something about it.
So it sounds like the first stage is monitoring the assets, and then you're moving to the stage where it's predicting outages. What's the kind of time frame like between those two when you do a deployment?
So it's an interesting question, and of course we've been talking a lot about information in this short conversation that we've had, and it really does depend on the availability of the information. But what I would say, and what we've successfully worked through with a number of customers in Australia, in Europe, and also in the United States, is to actually not use the lack of information as a barrier. Okay, there are things that can be done. You can start with some basic capabilities and then identify that additional information that you perhaps thought you had, or perhaps no, you don't have, but start to collect that as you do work and as you operate, and then slowly grow into that functionality. And that's really, if you like, one of the capabilities of the system is, first of all, we've designed this system so that it's very open, so that you can use our network management system for specific functions. If you just want to manage, for example, distributed energy resources, or if you want to use our system to look at the low voltage network and collaborate with your existing infrastructure for your high voltage and your medium voltage, then the system's been designed to enable that, to use information exchange standards, which are common in the industry, to be able to exchange those control signals and that visibility of information so that we can present one unified view. So the lack of information should not be a barrier. I think what we've done and proved with many of our customers, and indeed, we've got case studies out there on the web that talk about this, is perhaps we've started with some basic outage management. We've started to move into some of the power flow calculation and power flow simulation to forecast what's happening in the network, and slowly but surely introduce more capability and more active control, where we might be managing voltage to optimize technical loss, or perhaps to be able to deal with certain constraints that may be occurring where we need to get slightly more capacity through the network for a short period of time.
Julian, I just want to ask you one more question before we finish. What about at the very sharp end of network outage management, such as we've seen in the US, millions of customers out?
Absolutely.
How would your, an analytics approach, a low voltage visibility, how would that have made a difference in that scenario?
So again, you've got to be able to take in, if you think about it, particularly with, if you've got smart meter deployments and so on, those smart meters, if they're working on a GPRS or have got some communication method to be able to communicate last gasp, you've got huge volumes of information that are telling you, something's happened. And what you need to be able to do, and we've proven this in many examples. Storm Maria being one of the recent ones, where our customers have been dealing with, and the devastation is just, something we just can't even contemplate here, in Europe, because we don't get those severe weather events, and a lot of our network is underground, which helps a little bit. But what you've got to do is bring that information together. You've got to use automation to digest and condense that information and turn that into actionable intelligence that the control engineers can deal with, to be able to actually prioritize by criticality which outages you need to address and systematically restore power. And our system helps with those very experienced engineers to be able to filter that information and provide them with the data that they can take action systematically to restore power. One of the things that we're always listening to our customers. It's a key ingredient of our whole product and solution strategy, and we have a lot of special interest groups and so on that our customers can feed into with their ideas and suggestions. And we listen very carefully through the storm season to how the system performed, where we could have done better, and so on. One of the things that we're certainly doing is embracing mobility, okay, and being able to actually put more information and more real-time information in the hands of the field engineers, so that they can visibly see the network, so that as damage assessment is coming in, you can actually get a clear visual of what the damage is, understand what the types of resources and equipment are going to be needed to address those damages systematically. I think one of the other things, and we're very close to some of the action here. We're seeing a lot of interest in how do we actually get more of that damage assessment. What can we do in terms of using drones and automation to be able to get more of that visibility? And again, although we won't be making the drones, well, never say never, but as far as I know, we're not going to make an Oracle drone, but we will take that information and the types of data that those drones can collect and be able to do that analysis that determines, what damage has been created, provide that to those engineers so that they can take actionable and those key decisions.
Interesting stuff. Thank you, Julian. Thank you for joining us.
Thank you for the opportunity.
That's all from the Engerati studio. You can watch plenty more of our videos on our YouTube channel.